Page IN1, lesson IN1 is on prime factorization. So Flynn and Eden are playing a number game. They each need to find a way to make their target number by multiplying only the numbers on the tiles. So Flynn is trying to get to 28, Eden's trying to get to 20. So part A, it says Flynn's target number is 28. Which tiles could Flynn use to create a multiplication expression with a product of 28? So one way to do this, we could do 7 times 2 times 2. We could do the order differently. Like if you said 2 times 2 times 7, or 2 times 7 times 2, okay? We'll consider that pretty much to be all the same. So some combination of a 7 and 2 2's being multiplied together to get 28. If you're not sure what to do, what you could do is just think about what numbers could I multiply to get 28. You might think of 4 times 7, and then think about, well, there's no 4, but to get 4, I could do 2 times 2. Another way of doing that, which we'll be getting into in this lesson, is you could do a prime factorization of that, and you could break it down into prime factors because those are all prime numbers on those tiles. So part B, Eden's target number is 20. Which tiles could Eden use to create a multiplication expression with a product of 20? So if you look at the tiles there, they could do 2 times 2 times 5. And I guess we could show the tiles here so you can see both things at the same time, what we're doing. So part C, which tiles did both Flynn and Eden use? So they both used a 2. I guess since it says which tiles did they both use, they technically used 2 2's. So I guess we could say a 2 and a 2 that they both use. Probably either one would be okay for that. So example 1, whole numbers greater than 1 are either prime or composite numbers. A composite number can be written as a product of its prime factors called its prime factorization. So prime factorization, we have a number written as a product of its prime factors. So if you look, it says, how can you find the prime factorization of 48? Before we get into that, here's some definitions. So 5 is a prime number because the only factors of 5 are 1 and 5. I'm going to give a little more of a definition here. Prime number has only 2 factors, 1 in itself. The only whole numbers we can multiply to get 5 would be 1 times 5. Okay, you say 5 times 1, well, that's the same thing. Okay, that's a prime number. Composite number has more than 2 factors. So for example, 12, we can do 1 times 12, but we've got other options. We can do 2 times 6, we can do 3 times 4. As long as there's at least one other option besides 1 times the number, then it's called a composite number. Okay, so composite, another way of thinking about that, we'll talk about in a minute. A factor tree, if you can break it down further using a factor tree, then it's composite. If you can't break it down any further, then it's prime. So factor tree shows the prime factorization of a composite number. Factor trees can look different for the same number, just depending how you break the number down. So 48 here, the book said, oh, 48's an even number. Let's say it's 2 times 24. 24 is an even number. That's 2 times 12. 12 is an even number. That's 2 times 6. 6 is an even number. That's 2 times 3. So that's that factor tree. We could actually do a factor tree for 48 and it would look different than what they had. So besides doing 2 times 24, so one option would be 4 times 12. And then we could break down 4 as 2 times 2, 12 is 2 times 6, 6 is 2 times 3. So that factor tree looks different, but if you'll notice what we have here and what the book has, both of them have 4 factors of 2 and 1 factor of 3. We could have also done 48 as 6 times 8. 6 is 2 times 3. 8 is 2 times 4, and 4 is 2 times 2. I like to, if I can think of it, I like to try to think of factors that are closer to each other, because what it does, it makes it to where my factor tree is not as long. It doesn't take up as much room on my paper. But either way, we're going to get the same answer. When we do this, when it asks for the prime factorization, what we're doing is we're taking all the prime factors. And what I like to do is circle these. The book's got them in red, but we're going to just be using pencil, so probably circling them would be a good idea. We're going to take all those and we're going to say those are all being multiplied together. If we multiplied all those together, that would give us 48. Now, rather than writing this all out, 2 times 2 times 2 times 2 times 3, we can do a little bit of a condensed version of that. And we can say it's 2 to the 4th power times 3. We can use an exponent if we have a repeated factor, okay? Probably a math teacher had to read all these answers off, and they're like, let's find an easier way so we don't have to read all these answers out. Let's do these exponents. No. But that is a way that we can have it condensed down. And then also for you guys, then you don't have to write as much stuff out too. So on the try it, they want us to find the prime factorization of 56, and it says start with the least prime factor. So what that means is after we've broken it down, whatever the lowest prime number is, we're going to start with our lowest prime numbers and work our way to our biggest prime numbers. So the book doesn't really do it the same way, but if you want to, you can go off to the side somewhere or on a separate paper and do a factor tree to break this down. I think the factor trees are easier, but if you want to do what the book's doing, that works too. So this might ring a bell. Multiplication facts, 56 is 8 times 7. The 8 can still be broken down as 4 times 2. The 7 is a prime number, so we can go ahead and circle that. The 4 can be broken down as 2 times 2. And then the 2's are also prime. So like we could say, oh, 2 is 2 times 1. And then we could say 2 is 2 times 1. We'd be there all day, right? They're already prime numbers. We don't have to go any further with that. Okay? And now we're going to write this in prime factorization. Doing a factor tree is not giving the prime factorization. This is not answering the question yet. We did most of the work. We got to have the final answer written out using prime factorization. So if we go back over here, what the book's showing, prime factorization is, if you want to start off 2 times 2 times 2 times 7, ultimately our final goal is going to be this right here. 2 cubed times 7, or 2 to the 3rd power times 7 is our prime factorization. The next thing they talk about, if you look at example 2, they talk about greatest common factor. Greatest common factor, a way to try to help you remember this, I tried to make up a little acronym here for greatest common factor. To find greatest common factor, we can get prime factors, circle the matches with different colors, and then factors you match get multiplied. That's one way of finding the greatest common factor. And factors, probably be good to know what that is. Factors are numbers you multiply together to get another number. So they don't have a real great spot maybe to put that in there. So if you find a spot, otherwise if you want to put that in your notebook about greatest common factor. So one way of thinking about greatest common factor, it's kind of like the biggest number that the numbers could both be divided by evenly. When you look at numbers, sometimes you might have an idea of what the greatest common factor is, but sometimes it's still good to just work the problem out, just to make sure that you've actually got the greatest common factor, that you've got everything and not just part of it. You know, it's getting the prime factors, and then so if you look at example 2, Keisha is putting together bags of supplies. She puts an equal number of craft sticks and an equal number of glue sticks in each bag. There are no supplies left over. What is the greatest number of bags of supplies that Keisha can make? So if you look over here, you can see there's 12 bottles of glue and 42 craft sticks. So the book magically had prime factorizations. We would probably be doing factor trees in order to come up with that. Okay, they're not showing all the work just because they want to make your book lighter so you don't have pages and pages of every little detail they did. But you know, this would be maybe breaking this down. Okay, prime factorization. Okay, and then like I said, we got to get the common factors, and then we're going to circle the ones that are in common. If you want to color the matches, like I said, circle them with different colors. So if you look at this, you can see they both have a 2 in common, and they both have a 3 in common. And then the factors we match, they get multiplied. So they both had a 2, and they both had a 3. If you multiply, that's 6. So the greatest common factor is 6. What that means, both of those numbers, 12 and 42, are both divisible by 6. And that's the highest number we can divide both of them by evenly. What that means, then we could make 6 bags of supplies. If we made 6 bags of supplies, each bag would have 2 bottles of glue and 7 craft sticks, if that makes sense. So if we look at the try it, explain how to use prime factorization to find greatest common factor of 18 and 45. So 18 and 45 we can break down. Again, you might have an idea of what you think the biggest number is we can divide them by. We're just going to do the factor trees just to double check, just to make sure we're not missing anything. So 18 we could break down as 2 times 9. Then the 2 is prime. The 9 we could break down further as 3 times 3. So 45 then is 9 times 5. And then the 9 is 3 times 3. The 5 is a prime number, so we can go ahead and circle that. Okay, at this point we're looking for matches. Okay, this is like the memory game. We're finding matches. So they actually both have a couple of things in common. So if you look at this, you can say, oh, they both have a 3 in common. And then if you look, they both have another 3 in common. Okay? So they had a 3, they had another 3. So at that point, we would just multiply those together. 3 times 3 is 9. So 9 is our greatest common factor. In other words, the biggest number that 18 and 45 could both be divided by evenly would be to divide them by 9. And again, looking at the numbers, you might have thought that from the get-go. You might have looked at 18 and 45 and right away just said, oh, they're divisible by 9. Okay, and that's great. Occasionally, even if you're really good at this, occasionally there will be numbers where you just won't see something of a higher number that works. Like if it was 18 and 72, 18 and 72 actually have an 18 in common. So you might have thought 9 again there, but actually those have an 18 in common. So anyway, just something to think about when you do greatest common factors.